Let's see if it's any good. I'm going to take a first look at OpenAI's ChatGPT search and see what kind of results it serves up. ChatGPT search is currently only available for ChatGPT Plus ChatGPT team users and SearchGPT waitlist users, although the waitlist for SearchGPT is now closed. ChatGPT search will be for users for free in the coming months. So since I'm a ChatGPT Plus subscriber, when I log into ChatGPT and I'm using ChatGPT 4, I now see a small globe in the message ChatGPT field. When you hover over it, you'll see search the web. You must click on the globe icon to enable ChatGPT search. Click on it and a list of trending topics will appear. I see information about the 2024 US election and some celebrity news, including the death of the legendary music producer Quincy Jones. So I'm a big fan of Quincy Jones. I'm going to ask, what was Quincy Jones's most famous song? And here are the results. ChatGPT natural language, and it says that Michael Jackson's song Thriller, which is the title track to the album, was the biggest album in history. It also mentions that another one of Quincy Jones's productions, Soul Bossa Nova, has gained widespread recognition. As you can see from ChatGPT, it adds a clickable link to his Wikipedia page and YouTube Music if you want to hear a playlist of Quincy Jones music. Unfortunately, I can't play y'all because we'll get flagged, but it's nice to have a direct link to famous work. Below ChatGPT's answer is a small window that says sources. Click on it and you'll see a list of links with citations and news about Quincy Jones, including the Wall Street Journal, Vanity Fair, and Pitchfork, or any news outlet that reported on the death of the person. Let's try another search. I'm taking my family on Array for the weekend, so let's see if ChatGPT has any good suggestions for what we should do while we're there. So I'm going to click on the ChatGPT search icon and ask it. Let's see what it comes up with. So it did provide some images. The first thing it says is the Monterey Bay Aquarium, and it has a link with tips with little hikes, but my kids are 10 and 12, so they're not links. We are going to go there. We are going to go to Cannery Row probably. Monterey Bay Coastal Recreation Trail, watching tours, probably won't do that. Fisherman's Wharf, Dennis the Menace, that sounds kind of fun. My kids might like that. The Monarch Butterfly Sanctuary and the 17-mile drive through Pebble Beach. Ooh, I'm a big golfer, so I'd love to drive through Pebble Beach. That would be amazing. Now, if I look at sources, it puts sources in the right rail. And it types, and it's all the sources that were included in each of those little answers it gave me. So that's pretty cool. And then it has some pictures. So yeah, this is kind of helpful. I did hear that there was a haunted mansion tour in Monterey, so I'm going to ask it about that. Yes, Monterey offers haunted tours that delve into its rich and eerie history. The Cannery Row Ghost Tours, Monterey Ghost Walking Tour by the U.S. Ghost Adventures, and the Haunt Ghost Tours. So I might check some of those out just because, you know, it might be fun to check out some haunted mansions, and why not? So if I click on this link here, Haunted Ghost Tour. It's past Halloween, but still, it might be fun to go. To switch your defaults to ChatGPT, you'll see the option to get the extension near the bottom of the page. So I'll quickly walk you through getting the extension and setting it up. So I'm just going to simply go down here and click Get Extension. It has an overview, some information, some reviews. So I'm just going to click Add to Chrome, Add Extension, and bam, there it is right there. So I'm going to test it out real quick and just open a new tab in Google Chrome and just ask it about CNET. Tell me about CNET. And bam, it goes straight to ChatGPT Plus, all about CNET.com. So if you read ChatGPT, this is pretty awesome. This extension just works automatically. I don't have to do anything. I don't have to click on it and then start a search. It'll just open a new tab and it's ChatGPT. How cool is that. So when I did my first search, it said change back to Google search, for me to use ChatGPT search. Then it gives you the option to change it back or keep it. I'm going to keep it for now. I'm going to try one more. Tell me about Pebble Beach. Drive through Pebble Beach. It's serving me up pictures and it's telling me all about Pebble Beach. And it's note that the 17-mile drive is a two-lane road allowing travel in both directions. And it's advisable to allocate at least a few hours to fully appreciate the scenic beauty and attractions along the route. So it's giving me a little advice on how much time I need to take and the size of the road. So that's all kind of helpful stuff. We're going to check it out. That's how to use OpenAI's new ChatGPT search, which is a direct competitor to Google's Gemini. Let me know in the comments what your go-to AI search engine is, and subscribe to CNET's massive YouTube channel for more AI news. Thanks for watching.
Hi guys, I hope mko poa. I think tupewe watu a few more minutes. Tukifika around 5 to 10 people, we can start. Yeah, sure. Niambie, what's the problem? What's the error you're I hope unaweza unmute and and talk. I don't know why you can't unmute. Uh, try unmuting right now. Nimekupea right. I think you can unmute. Hi, ni Alvin. Hi. Nakusikia, niambie.
Yeah, there's a problem. Every time najaribu kuinstall Langchain, hizo tu nini zote, I keep running into this problem.
Okay.
Wait a minute.
Abu
This doesn't
type
seem like.
the packages have been installed. It's just you
Yeah.
need to upgrade to a new version of npm.
Oh well. That's it, Basi. If I've gotten through this,
Uh,
yeah, I can catch up. Wow.
you pulled the code from GitHub.
Not that was the nini. That was the goal. I just needed to
Okay.
make sure that I had
Okay.
an environment first. Yeah.
Okay, ni sawa.
Thanks.
Poa. So thank you guys for coming for today's session. Hata kama tuko as many as last time, we'll still continue. So today we're going to build an application called a conversational RAG application. So there are two parts there, conversational and RAG. So I'll start with RAG. RAG for retrieval augmented generation. So that means that for an AI application that unataka ikuwe na some external source of information, you need to implement a RAG pipeline such that you get that external source of information. So, for example, a certain document, a certain article, and then you use that document as your new context or new information for the AI system to generate an output. So the RAG pipeline starts from the retrieval part. So the retrieval part part is a part where you retrieve from a database that contains this that you have that you want to use as your context. So for example, you have let me present and show you guys something. This window. Hi, Rebecca. Let me first of all even go through what we did last week so that you can catch up. Last week we built a Langchain chatbot, and the program the library that we are using to build AI chatbots is Langchain. Langchain, their website is this one. You can go /Langchain, and then you use that you want, whether it is the Python one. Currently, we're using JavaScript because the aim is to go into to build where you can ask who is the US president, and then it will go and do a web search, and then it will search and tell you that as of now Joe Biden is a president. However, the elections have taken place and former President Trump is the one who seems to have won the election. So that is a system that we will eventually build. So, the library we are using is called Lab. So what we did last week was we built a chatbot, and we started off by building a simple chatbot that you could ask a question and then it responds, but not have memory or conversation history. So this is the code that we used, and you can see it working right here when we do node part1.js. Yeah, so here you can ask it, for example, when was the last US election? And then it generates for you a response, and then it tells you it was on November 8, 2022, and you can ask who won the elections. So it now has context of which election we're talking about, which is the last one. Then it tells you that Vice President Harris and who else? Yeah, so it has context of what we're talking about. This is what we built last time. So today we are building an application that will have information from an external source. So instead of having to use the knowledge that the AI system has, we will use an external source. Okay, sorry. I don't know. Sorry. Let me share. Sorry. Okay. So this is the question I asked. I hope Saim mnaeza. So I asked, when was the last US election generated this? And then I asked who won the elections. Said these are the people who won, like that. So today we're going to build, now to have an external source of information, such that instead of relying on the information that the AI system was trained on, you can ask it a question from retrieve that information from a certain document. So yeah, so that's what we did last time. So today we are going to build a similar thing, but we're going to start from scratch so that you see how the whole process goes about. So the first thing we need to do, or first of all, I was explaining a RAG application is, and I was here. This is how a RAG pipeline looks. You have argument for this explanation that for what we're going to build today, we're going to use this article. You're going to see it better when we ask questions about it. So this is a very long article about LLM powered autonomous agents. So it has so much information. So this is the source, our external source of information. So with this source of information, we are going to split this long source of information into things called documents or chunks, such that this whole system, this whole document, is going to be split into chunks. So, for example, we are going to choose to split this document into chunks of 100 characters, 1,000 characters for each chunk. So you're going to do 1, 2, 3, 4 like that, and split for 1,000. For one chunk will be 1,000 characters. So that will be one chunk. The reason why we're doing this is so that we are doing the retrieval process later on, instead of retrieving the whole document, we're going to retrieve certain chunks, have context relevant to a specific question. So you might ask a question like stories that are there. So instead of getting this whole document like that and giving it into the context of our AI system, we are going to only get the chunks that are going to be in this section. So from there up to there. So those are the chunks that will be gotten from here are the ones that are going to be used for that question. So that saves on cost, because AI systems rely on tokens, and the more the tokens that you are providing an AI system with, the more the cost you're being charged by the AI provider. So the less the number of tokens you're going to use, the better. So instead of uploading this whole document, we're just going to get the chunks that are memory section, because our question was how many types of memories do we have. So a sensory, short-term, and long-term memory. I hope that makes sense. So so that those are the documents or chunks. They're the same. They are same thing, and those documents are saved into a vector database, just like you would save your users in a normal SQL database or NoSQL database. Now for AI systems, they use something called a vector database. So a vector database is like storing. So for example, you have a text, like for example, long-term memory, and then you want to store this vector database. First of all, it goes through a process called embedding. So embedding is just converting this from text format into number format. So in the vocabulary of, for example, we're going to use OpenAI. So in the vocabulary of GPT-4, the certain words or certain tokens. So from, if you remember last week's session, tokens, and we saw that for each GPT-4 doesn't use letters or words the way we think about it. So for example, here we can have like 1 or 2. For example, we use 3 tokens just for simplicity's sake. So each of these words, long-term memory, has a number equivalent. So instead of saving this piece of text, long-term memory, as a string of, it is saved as a list of numbers. So for example, long could be 5, number 5. Term could be number 6. Memory could be number 200 and something. So those numbers, that list of numbers, are the ones that are saved into a vector database. So if you remember, in high school, we did vectors and matrices. So just the way, using that concept, that's how a vector database looks like. It is a list of numbers that are stored in a database that are the equivalent. When you convert them back into text format, you get the documents that you have embedded. So that's how a vector database works. And then, so a user asks a question, and then that question is taken into a vector database, and you do a search. Just the way you do a normal search in your normal SQL database, if you're looking for a certain user, that's just a similar concept you do in a vector database. You do, like, for example, the user has asked, what are the types of memories that there are. So the query there is looking specifically for types of memory. So you're going to take that query, types of memory, and then in your vector database, you're going to do a search, and you look for the um, uh, list of the documents that you've already embedded and stored in your vector database that have um, uh, types of memory as their contents. So you will get, once you do that, you will get your top K chunks, and your top K chunks, you're the one who decides what K is. So you can get your top 10 chunks, or you can get your top 5 chunks, depending on the amount of context you want to give your LLM, so that you get a response from that. So that's basic remaining bit here. So you do top 10 chunks, you get 10 chunks, and then you combine those chunks. Now, after this, it's going to be called context. So now you combine the context, the top K chunks, with your user query, and then you pass it to the LLM, and the LLM will answer the user query depending on the context of the top K chunks that you've given, and then it will generate for you a response. So that's basically how a RAG pipeline works. So we are going to build something like this, and as I said, this is the document that we are going to get our information, our external source of information from. So we'll come to our IDE. So we'll write some code, conversational, and close that, close that, close that. Okay. So we'll start by, the first thing we need to do is to define our LLM, and we do that like that, just like we did last week. The next thing we need to do is we need to define something called a loader. A loader is the one that is going to load the external source of information. So we're going to import a class called Cheerio web-based loader from the Langchain community. We do const equals require like that. And then that means that we need to install Langchain community. For those who are new, we did some installations last time. We installed Langchain core, we installed Langchain langgraph, we installed Langchain, we installed .env and UUID. So if you want to continue with us like the best possible way, you need to install these packages, and you can find them kwa the GitHub repo that I posted kwa group. Let's check it out. It's this one. I can post there so that anyone who. So if you want to follow through with us, you can use that. So we're installing Langchain community. So let's wait for that to finish. In the meantime, first of all, you need to install to create, and the loader is using Cheerio web-based loader. For those who have done web scraping, Cheerio is a web scraping library or tool. So so Langchain have just built a wrapper around Cheerio such that it is usable in their Langchain library. So the selectors we're going to do is post content, post title, and post header. The reason why we are doing this is because in this document, in this article, the post content, I don't know if you can see down here. So post content, this is the contains the information. So post content is the one that contains the post header, the one that contains the header. When you go to the top here, when you hover over here, you see that that's the post header, and the post title is just the title itself. So that's why we're using those classes so that we get the text in those in those tags in short. So here we're using h1, here is the header, and here is a div. So all there we get it using the class selector here, like that. So that's the loader. We've created the loader. The next thing we need to do is we need to split the text that we are loading. So this piece of code here is just loading the loader that we've defined into a variable called docs2. We can call it docs for now, doesn't matter. Loader like that. And then now here, this is the splitter that we're going to use to split the text into chunks of 1,000 characters. You see, this is called a recursive character text splitter. So it recursively splits the content into characters so it will be 1,000 characters for each chunk. And then here when we say chunk overlap is, so let's come back here, let me show you what chunk overlap is. So for example, split your text into chunks, and you have your first chunk as planning, like that. This is your first chunk. I hope you can see that well. So this is your first chunk here, and then is memory, like that. But so that these two have some sort of where they are in terms of the whole document, so that ijue that memory inakuja after planning. So you put some chunk overlap such that this chunk for memory haitaanza from the word memory, itaanza from somewhere like from this line hapa kwa learn from mistakes, like that it will run all the way to somewhere there. So this chunk, but the 1000 characters, 1000 in quotes because 6000 characters are this one, but because tunataka ikuwe na some sort of context in the whole document, ndio ijue I am coming after and before tool use, ama I am in this context, this chunk is being used in this, so that ikuwe na hiyo context, itakuwa na chunk overlap here there na up to somewhere there, so that will be the whole chunk when you from the vector database. Same thing with planning. So planning tulisema that is the 1000 characters, and then having just that, it will start from somewhere there and run all the way to there. So that will be the one chunk, so that ikuwe na context. So that is what the chunk overlap does. It ensures that the chunk itself has some sort of context in where it is being used, so that the AI system doesn't use it the wrong way. So we've imported this, so we do const that record. Like that. So we have our text splitter, we have that, we'll define that. The next thing we need to do is split the documents, and we are splitting the documents, and then we're going to store them into a vector database. So this is the code to do that. We're calling it the splits are a list of documents. As you can see, me here that dealing a list, but it's a list of type documents. And so we're using the text splitter that we've defined to split the documents. And these docs here, okay, click here, you see it brings us here. We are splitting them, and that we can console log the splits. Okay. Before we even continue, I want us to do something. First of all, let's put this in one function so that we can get the function to run. We do const. Okay. Like that. Okay, so now after we've split, we'll console log and see the split. Next thing we need is to import the store. So the vector store that we're using will store the documents. So we're going to store the splits that we've split here, and then we're going to use the OpenAI function for embedding, so that we embed the text into a number format or a list of numbers that we can store in the vector database. Remember, the vector database only deals with embeddings, which are in number or float format. They are not strings. So we need this function to build this function to actually embed. So that's it. Then we call it vector store like that. Yeah. We can console log and see the splits. Let's see if this will work. It's called here the main. So we yeah. My ID has hanged. Okay, let's come to package.json and see. Okay, so start is node index, so it can. Let's see what the error says here. Not defined. Okay. We need to come here and deal with this error. Let's see if that fixes it. The package subpath memory is not defined by experts. Okay, Langchain. Let's see if this works. This should. Langchain. One second. Let me see if there's a package I haven't installed. Let's try that. Okay, that has worked. Cheerio. Cannot find Cheerio from. Okay, let's try and install. I don't know why it's bringing me this. should be. Yes, finally it has worked. So is this list of documents we've, we've done console log the splits, and we can now see here we have a list of documents. And you can see that here we have the first document is here at in an LLM system planning. Then you see that since we have created it to have 200 characters, let's see if it is obeying that planning sub goal. It doesn't seem to be having 200 characters. I don't know why that's not happening, but we can see that it is having the planning that it has ended with. It is starting with it here, and then also here in the next document it is not doing the same. I'll have to figure out why that is not happening, but we can still continue. And so now we've created the splits, we have the documents. Now we just need to create a chatbot that is retrieving this information from this vector store and then using it to answer a question. But before we need to understand something. For it to actually answer the question, it needs to retrieve the information from the from the vector store. So we first of all come here and create system prompt. So we do const system prompt, and we tell it this. So we tell it you're an assistant for question answering tasks. Use the following pieces of retrieved context to say that you do not know. Use sentences maximum to keep your answer concise. So here where we have addresses context is where the documents that are vector store are going to be input into the system prompt so that it refers to those documents to answer the question. So this is where the context is going to be Can you guys hear me now? Okay. Sorry. I don't know what happened. I was. I don't think I changed anything. Let me just finish up so that we can see how um, this works. So I was importing the right way so that we don't get an error. So const and require. Um, so these are the right imports. Yeah, sure. VC can unmute and speak.
Yeah, we can't see your screen. I don't know if you're sharing it or not.
Oh yeah, let me share. Yeah, so I've just imported these two lines so that we can use these two pieces of code here. So we've imported create staff documents and chat prompt template. So yeah, so finally, before we get to see the application running, we sorry, this 1 second. Oh, sorry, there's something going on outside. So I'm saying we've created this prompt structure where we have a system prompt, and the system prompt is this: you're an assistant for question and answering tasks, and we've told it to use the context that is going to be inputted here. In the prompt, we have that system prompt. We also have the human structure where it takes in human from the user input or user query, and it puts the text or the user query here, so that this is a prompt structure that is going to be inputted into the LLM. So we first of all created the question answering chain, and a chain in Langchain is just a runnable sequence of functions that have been put together such that they can be run consecutively one after the other one. So the first thing that we put into this chain is the LLM, and then inside the LLM we are chaining it the prompt, so that when this is run, the LLM the prompt is given access to the LLM, such that when you ask it the question, the LLM is the one that runs and responds to you. So that's the first chain that we've created, and that's the question answering chain. And we're using create staff documents chain from Langchain to do that. The next thing we're needing to do is to build a RAG chain. A RAG chain is now the one that has the retriever, the one that retrieves information from the vector database that we created up there. Yeah, the vector database that here is a vector store, the vector database that we have where we've stored the documents. These documents that you can see here in the console have been stored in a vector store that we have defined here. So we need to give it the retriever function. So the retriever is this one that we defined here. So it is vector store. This vector store is, so we've defined a retriever on it such that it retrieves information from that vector store. So we've passed the retriever into that RAG chain that we are creating, and then we are combining together with the docs chain. So the docs chain is this one that we created here. So together, the retriever together with the docs chain. The docs chain is the one that contains the prompt and the LLM that are here. So let's import create retrieval chain. We're getting it from Langchain chains retrieval. So let's import it like that. Require like that. So now this should have gone. Yeah, it has gone. And then finally, now we can do const response ragchain.invoke. We pass it into it the input. So what is task? So we can ask it a question like what are the types of memories? So then we can console log the response so that you can see it, and we can also let me see if we can also do I don't know if we can do console that we can see the documents. Console.log retriever I don't know. I don't think we can get. Let me see if there's a way I can show the documents that I'm using to answer that question. Let's first of all see if it's actually outputting the response, and then we can figure out how to get the documents shown. Let's remove this. Let's run this again. So we've asked it a question. Question is, what are the types of memories? So there's an error. I can't read properties of undefined reading from documents. Let me see what that error is talking about. Just confirm Langchain is installed. So we have Langchain, then slash vector stores slash memories. This should work. Yes. So now we can see here, clearly that we gave it an input. What are the types of memories? And so this chat history, which we are going to we're not going to be able to implement it today, but we're going to do it such that we can ask it a question in the future, and that is regarding this context, and it will be able to answer it. But the next thing we can see here is the context, and we are seeing here we have figure 8, categorization of human memory. There is that first document. There's another document there, another one there, and another one there. So I think those are 5 of them, and then the answer. So out of these documents, it has gathered that the types of memories include sensory memory, short-term memory, long-term memory, and then it gives a short description of what it is getting. So that is a simple RAG application where you have an external source of information and you want your AI chatbot to be able to answer you with information from that external source. So now for this example, we are using this document this article here. You can upgrade this from just from not just using a vector store that has a single article. You can have a vector store that has multiple articles, or you can have a vector store that has lots of company data things like that. And then you can build an application around that such that users can ask it a question and it can generate an output, and it can also give you such now this will use it as citations, such that in together with this answer you can augment this answer such that you show you tell the user, here are the citations. So you can list the documents, these documents, each one of them and the content, and then the user can be able to see that truly that this answer is actually being gotten from these documents that have been provided. So that's a simple RAG application. Today we weren't able to build the full conversational RAG that I wanted us to build. The conversational part is the ability to hold chat history here. So I think we'll have to do that next week. And I hope you've been able to see how we are building a RAG application. So just to review, we need to have a loader, and the loader here is to load information from somewhere before you put it into a vector database. So you load the information from somewhere, whether it is just one article or it is a list of articles. So here you can have a list of web paths. You can have a list here, and then you can have the fields that you want to get. Then you save that as docs. Then you have a splitter that splits it into chunks, each and every in terms of the characters are chunked. And then you store those chunks into a vector store, and a vector store stores the chunks in number format, in embeddings format, such that they're not in strings or characters, but they are in floating numbers. So there's that. And then now, after you've built your vector store, you need to build a retriever. So a retriever is the one that now retrieves information from that. So this is your retriever. And this system prompt is the one that tells the AI agent what to do with the context that will be passed in here. So it does what we defined here. And then you define a prompt structure where you give it the system prompt and the human prompt structure where the input will be put in there. And then here you just give it these two chains. The first chain contains element prompt. The second chain, the one that actually does the retriever. So with that, you can do a rag chain.invoke with the input, and you get your response here, like we've seen down here. So Gideon, you asked, are we guaranteed that all articles user the class selectors we've used? Yeah, all the selectors here that we defined, post.content, it contains all the subtopics. I don't know how I can show you. I've zoomed out to the maximum so that you see that when we come here to elements and you do, we just click. So here we have post.content. This div contains all the information that you would want. All this information is inside the div called post with the class post.content. So all this text information here is stored in the vector store. So you can ask a different question. So like for example, let's see what other subtopic we have here. We have proof of concept examples. I don't know what type of question we can ask about that. We can ask a different question like define for us self-reflection. So we can do what is self-reflection? Do what is self-reflection? Then we can run that. So this will go to that document and get all the chunks that are talking about self-reflection, and then it will output for us. So self-reflection is a process that allows autonomous agents to improve by refining past actions and correcting mistakes. So you can see here that we have self-reflection. Then self-reflection is a vital aspect that allows autonomous. So if you are still not convinced, we can do it like this, side by side with. So here you can see that the subtopic here, self-reflection, and self-reflection here, even with the hashtag there, and then self-reflection is a vital aspect that allows autonomous agents. Self-reflection is vital. So every part of the article has been stored. I hope I've answered your question, Gideon. Let's try the question that Rebecca has asked. So we can ask it, for example, we ask, who is the president? Let's see what will happen. The answer here is I don't know. The reason being is in our system prompt, we told it that if you don't know the answer, say that you don't know. And also, so that we remove any sort of ambiguity, we should add here if the question, if the context does not have information regarding the user query, do not try and answer, so that it doesn't give you false information. But something that you should notice is that it still gives us documents, even if the question that we have asked is not in any way related to the content of our vector store. It still gives us documents, and you can ask yourself and wonder, why is it giving us documents, yet these documents have nothing to do with who the sitting president is. The reason why it is doing that is because of how the retrieval function works. So the retrieval function works in such a way where it takes all the documents in a vector store, all of them, and then it orders them in terms of which document has the most context or has the best ability to answer the user query. So it doesn't necessarily mean that the ones that have the user query are the ones that are the ones that have context are the ones that are listed on top. It just means that it is ordering all of them. Sorry, one second. Kona homa baya. 1 second. The documents that are, or the chunks, are all listed in order of which one has the most context to answer. So unaweza kuta hata ile question haiko totally related na the source ama the the information the vendor store, you will still get documents for it. But the AI system is smart enough to know that hizi documents zimepewa haziwezi jibu ile question yenye the user ameuliza, so it won't answer, and that is all to do with the system prompt. So you also need to be careful that your system prompt is not ambiguous at all, such that it allows it to answer. So for example, inaweza answer this question, but venye tumeweka prompt yetu haita answer. But if you want your AI system to be able to answer the questions in such a way where it can ask, it can choose whether to answer the question depending on using the vector store, or also to answer the question with its own internal knowledge. Now you need to go into something called building an agent. So an agent is an AI system that has the ability to manipulate its environment, or to use the tools within its disposal to perform a certain. You can build an agent that can access the vector store database, but can also answer the question with its own internal information. So you can add here just to simulate something like that. If you don't know the answer, say that you don't know. Ama, instead of saying that, you can do, if you don't know the answer, use your own internal knowledge to answer. Let's see if this will be able to work and tell us an answer. But the best way is to build an agent that has a tool that can call the vector store, and an agent that can call another AI system and tell you the answer. So here we can see that after we've changed the system prompt and told it to use your own internal knowledge to answer, it has told us that as of October 2023, the president of the United States is Joe Biden. If we go back to the old system prompt, it will tell us it doesn't know. So I hope I've answered your question, Rebecca. I'm seeing that you're still raising your hand. You can unmute and ask. I can't hear you. Hello, Rebecca. I can't hear you. I can hear you now.
Okay, I was saying, now you can still hear me. Okay, I was
Yeah.
saying, if sometimes you can be in a chatbot and then it can't answer a question, it redirects you to like an online page or article online that can best answer your question. Now, is there a code we can run that can outsource the knowledge we have given it, like garner more than what you just offered?
Yeah, I don't know if you were here in the beginning, but the aim is to create an AI system like this one. So we asked who is the US president, and then it tells us as of now, it gives us the information, and then it gives us also source links where when you click, it takes you to that website where you can read more about your question. So our end goal is to build such a tool. So
I
you
didn't
will
realize that
get
was the
there.
end goal. Oh, okay, sorry.
Yeah. So, but your question is still valid. So that means that with this system that we've currently built, we're going to build on top of it, such that instead of just having an article, a simple article like the one that we have here, we're going to build an agent that can call the web do a web search and give you a response, and also in addition to that give you like source URLs. So that's what we're eventually going to build. So we're building up to there. We're going to get there. We see you're asking, can it sources like Kaggle? Yes, it can to some extent. Okay, depending on how sophisticated you want your AI system to be. If you can build a loader that um, um, can fetch whether it is the list of models on Kaggle, the data sets on Kaggle. If you can build a loader that can do that, then it can get sources like that. Or even more complex, if you can build an agent that when you ask it a question, it actually goes onto the Kaggle website and searches for either models or data sets, things like that on the website, and then brings back information that is even better. So yes, it can. Agents use for generative AI systems like GPT-4 and Claude. So if you can build an agent, if you can think of any agent you'll be able to build, then you can build it, because um, the the LLMs give us the best reasoning capability, such that you can tell it do this and it does it, or I can ask it, you can give it a simple query and it can decide what to do with the query, and where to source the information from. So yeah, I hope I've answered that question. If there are no other questions, I think we'll stop there for today. Yeah, so thank you guys for attending. Today hatuja cover what we wanted to cover, but I hope next week we'll be able to cover what we want to cover today, and also what we will be to cover next week, so that to ensure that tumalize topic ya kubuild a chatbot, and then we can move on to other AI spaces or fields. So yeah, good night, mlale poa.